Exercise 4, calculating the number of moles and mass. This is going to be another two-part exercise. Now, this is going to be a really nice example because on the AP exam, including the quizzes and tests that you will receive in this course, there are going to be a lot of multi-part problems where one value allows you to calculate the next prompt. For example, free response questions have A, B, C, D, E, F, G, blah, blah, blah. You know, the A, I, A, I, A, I. They're multi-part, right? And so it's very, very common, more often than not, that the answer that you calculate in A or B is going to be a term that you need to have access to in order to make your calculation for C or D. Here, just like in exercise 3, we see that happening. So again, this is maybe a little bit easier and more fundamental than what you'll see on the AP exam, but this style of the first answer is going to help you get the second answer is very, very applicable. So cobalt, capital C, lowercase o, as opposed to capital C, capital O, which would be carbon monoxide. Cobalt is a metal that is added to steel to improve its resistance to corrosion. Again, a statement that does you absolutely no good. You might as well not even read that. Let's go to the prompt. Calculate. Calculate both the number of moles, right? So moles. Calculate the number of moles in a sample of cobalt containing this many atoms. 5.022 times, sorry, what? 5.00 times 10 to the 20 atoms. My mouth is getting ahead of my brain here. And the mass of that sample, right? Which sample? This sample. So we're going to calculate the number of moles, and we know that that mass, or that sample I should say, a little bit better, has 5.00 times 10 to the 20 atoms. Well, let's remember, I have number of particles. If I need to go to moles, I'm going to use Avogadro's number. So use Avogadro's number. Set up a conversion factor. Now for every 1 mole, there's 6.022 times 10 to the 23rd atoms. Atoms will disappear. My only unit is moles. But wait a minute. Calculate both the number of moles. Oh my gosh, I don't need another conversion factor. That's one of my answers. Goodness gracious. Let's go get some points. 5.00. Remember, it says times 10 to the 20. Times 10 to the 20 atoms. Remember, how do I type in times 10 to an exponent in this calculator? Second EE. You guys remember where the EE button is? Right there. Comma. Remember, so second EE. Exponent is 20. And what am I doing to that 5.00 times 10 to the 20? I am dividing by Avogadro's number. So, divide. I have Avogadro's number stored as A, so alpha A. I get a whole bunch of calculator vomit. Now, how many significant figures should I be using? Well, the only number that I have here is 5.00 times 10 to the 20. Remember, the times 10, the 10 or the 20, we don't consider that at all when we're not counting significant figures. And so it's just the 5.00. So it's going to be 3 significant figures. So the third significant figure would be right there. So what does that tell me to do? Keep it the same. 8.30 times 10, right? E to the what? Negative 4. What are my units? Moles. So first answer. Boom. Looking good. Looking good. But we're not done. We just calculated the number of moles in a sample of cobalt containing this number of atoms. But now we have to do the mass of that sample. Well, if I'm trying to calculate the mass of a sample, which would be over here, I have to start from moles. Well, I just calculated that value. So I'm going to take the number I just calculated, use the molar mass of that species to get to the mass in grams. So use that number, pull it down here, 8.30 times 10 to the negative 4th moles. What atom are we talking about? Cobalt. And let's go. We're going to use the molar mass. Actually, I'm using two different conventions at once here. Try not to get confused. I need moles on the bottom so that I can have grams on top. This is cobalt. So in 1 mole of cobalt, how many grams am I going to have? Where do I find that out? Periodic table. Cobalt right here, 58.93. 58.93. Notice that the moles of cobalt will cancel, so the only unit I'm going to have left is grams of cobalt. So let's do some calculating. Now, I already have the value that I started this calculation with in my calculator because I calculated it in step 1. And so I will simply do answer multiplied by 58.93, right? The molar mass of cobalt. Enter. And let me use this as an example because I'm planning on giving you note packets that always have the answers printed down here in the bottom right so that you can know as you go. If you try them before you watch the video, which would be awesome, by the way, if you try them before the video, you can have some feedback. You can have some feedback to how you're doing, to how your idea is really meshing. And by the way, even if you get it wrong in your initial try, that's still really, really important to learning. That's a really, really good habit to have. See if you can do it at first and can just see where you failed. When you see where you fail, you understand your weakness and you understand where you need to improve. So that's a very, very good practice in and of itself. But let's look at the answer that I got here. 0.0489 and a whole bunch of calculator vomit. I only need 3 significant figures. But look at the answer that's printed right here. 4.89. Well, it seems close to this, but the decimal has been moved. Right? There's a 489. There's a 489. But this one is a 0.0489. This one has 4.89 and then some whole bunch of gobbledygook here. Yes, these are the exact same values. This is scientific notation. This is standard notation. Notice that if we were to move this decimal 2 places, it would be right there, 4.89. We'd have 4.89. And if we moved the decimal 2 places, especially to the right in this situation, it would end up being times 10 to the negative 2. Grams of cobalt, what are my units that I already have written right here? Grams of cobalt. So we are golden. Now you might be asking, what should I write on the AP exam in order to get full credit? Should I write this value or should I write this value? The answer is either. Remember, these AP graders, yeah, they're old. Yeah, they're old chemists, which is even worse. But they're here to look. Their attitude truly is to search for examples of your understanding. And so if you generate this value, they get, like, they're good enough at numbers and math and chemistry to understand that these two numbers are the exact same thing. It is so easy to them to see that they're the same thing. So do not freak out if you write this and then some later you find out that this is the answer. These are the exact same values. So I am going to go ahead and report this in standard notation with 3 significant figures, while you understand that this value is the exact same value.